to start with.
We need
47. 47. I see it. So in 47 we have 125 minus 8y cubed. I cautioned you last time. Remember this book does not in chapter say descending order, a negative leading coefficient has to be out. But then in chapter 7 they say, oops, we actually should have done this in chapter 6, and I can't do that to you. So it is a binomial and it has to be arranged in descending order. And we do have to factor out the negative leading coefficient. Please do that, although the book doesn't say it. And now I know it's a binomial. It's in descending order. No greatest common factor. No, we already took care of the negative leading coefficient. So I'm down to special products. Is there a special product that we can apply here? And we have two options for minus and two options for plus. So now I have to identify whether these two terms are perfect squares or perfect cubes. If they are perfect squares, then I will use the difference of squares. If they are perfect cubes, then I will use the difference of cubes. Perfect cubes. So what cubed will give us 8y cubed? 2y. What cubed will give us 125? Yes. So we have 2y and then 5. First, let's establish, once you say the difference of cubes, then obviously I have to have ready a binomial times a trinomial, correct? Once you say the difference of cubes, you will have a binomial and trinomial. You already gave me the binomial, but let's start with the sequence of signs. If this is minus, what do I have here?
Minus.
Yes, and in the middle.
Plus.
Exactly. Minus minus plus or plus plus minus. And you already said 2y and you said 5. Now we have to fill in the trinomial. I squared 2y and I put it here. Four y squared. I multiply these two and I put it here. And then I square this and I put it here. So this is the correct factored form. I'm assuming the end of the book says 5 minus 2y, 5 minus 2y, and this is okay. I don't recommend it. Always remember the negative leading coefficient should be pulled out. Is this good enough? Okay, next question. Anything else you worked on or you would like to see here? Anyone?
37.
37. 37. Oh, I see it on the side. Okay, so 4t squared plus 36. 4t squared plus 36, and this is 37. Perfect. It's a binomial. It's in descending order. Yes. Greatest common factor? Yes. Negative leading coefficient? No. So what is the greatest common factor? 4. What do I have in parentheses? If I started with two terms, I must have two terms in here. So it's t squared plus 9. Is this factorable?
No.
No. It's a sum of squares. That's done. Very good. Next question. Anything else? Anything else? 27. 26, 27. Okay, 12. X squared plus 34x plus 24. Very good. It's a trinomial. It's in descending order. Greatest common factor? I just made this That's it. Okay, greatest common factor, what is it? Very good. What is left? Very good. Good. Plus? Good. Okay, trinomial, descending order, yes. Negative leading coefficient, no. Special product, I wish. I always wish for a special product because it's like this, boom, boom. But this is not a perfect square. That's not a perfect square. 1 is a leading coefficient, no. So I'm down with to the last possibility. So I think I pointed this out last time. This is really a summary of factoring. So you have to factor, when you have to factor a polynomial, make it in descending order. Pull out the greatest common factor and the negative leading coefficient together at the same time, in other words, or in any order you want. And then separate it in your head in 3 categories. If it's a binomial, you have 4 formulas. If it's a trinomial, you have 2 special products and 2 other options. 1 is a leading coefficient and not 1 is a leading coefficient. Polynomial is always the easiest. I shouldn't say easiest, depending on the problem, but I only have factoring by grouping. Okay, so then I'm down to the last option. This is the last option. If this doesn't work, it's not factorable. So now I have to find 2 numbers whose product is and whose sum is. What is the product? 72. And what is the sum?
17.
Good. Good. Since the product is positive, both numbers have to have the same sign. Since the sum is positive, I know exactly which sign they should have. Which sign should they have? Positive. Good. So now, can I find 2 numbers whose product is 72 and whose sum is 17? Becky?
8 and 9.
Good. In any order. 8 or 9 or 9 or 8. Very good. So then I go back with 2. Let's use a bracket and rewrite the expression or the polynomial. How do I rewrite the polynomial? Yes.
No, 9x
Okay, you want 9 first. It doesn't matter. It's gonna be the same thing.
plus 8x plus 5.
Good. What will I factor out from the first 2? So from the first 2, we have 3x. What is left in parentheses?
2x plus 3.
What do I have to have from the other 2? Otherwise, I can't continue.
2x plus 3.
Now, when I factor something, I don't cover it, with my whiteout, but I really don't look before I write it. I'm not just making this up. I don't look because who knows what I can write something and it's possible. We all make mistakes. So I need, remember, sign and factor. If you don't write the sign, then you're messing up the problem. So sign and number. That's it. So now 2 is out. The common factor now is
3x plus 4.
and 3x plus 4. The common factor is this. I pull it in front and then 3x plus 4. It doesn't matter if you write it as 3x plus 4 times 2x plus 3. It's the same thing. Good. Other questions? Is there anything else you worked on? And thank you for working on these problems. Is there anything else that you would like to go back to? Yes.
$95.
95. 95. 6 a cubed plus 10 a squared. Perfect. Descending order, yes. Greatest common factor, yes. I always hope for something to pull out, always. And then I always hope for special products. Those are the easiest. So what can I factor out here? 2a squared. What is left?
3a plus 5.
That's it. 3a plus 5 is a linear term. No one can factor that. That's the answer. That's it. Good. Is there anything else? This is a very, very good indication. Yes, please.
How was the care last class?
This was given like a month ago or 3 weeks ago, 2 weeks ago. You should have it. This is the only one I brought. Last time I gave one out. I will give it to you, but I need to use it. So this was done. We're almost done with it. So I'll give it to you. But I just needed a few more minutes. Okay. Anything else? Is there anything else? Okay. So let's go back. We were trying to finish the equations. And I think, where was I? Which was the last problem we did?
Page 5, you've got some problems on there, and then there's also page 6.
Did we start page 6?
We didn't start page 6.
Did we finish this?
I think you did C.
We
You were
did.
doing the problems on the top.
We did A, B, and C.
Yeah.
Okay, so we are in D now. Excellent. Okay, so we are going to have. We're going to look at these 5, and then the equations here, and then we start chapter 11. Okay. Good. Very good. Thank you. 2x cubed minus 50x equals 0. What is the degree of this polynomial? Yes. How many solutions do I have to find? Exactly 3. Degree 3, exactly 3. Remember, an equation I cannot divide by a variable. But I can always simplify it, and I will, by 2. So this is x cubed minus 25x equals 0. It's a binomial. It's in descending order. Greatest common factor. The answer is yes. What will I pull out? Yes, I cannot divide by it, but I have to keep it in the problem, but I can pull it out. Good. I pull out an x, and what is left in parentheses? Very good. Now I know from last time what I have to do with x squared minus 25. Yes, how? Excellent. Can anyone give us 3 solutions now? And it's done. Excellent. 0 from here, -5 from here, and 5 from here. Do we all agree with this? 3 solutions because the degree was 3. Degree 3 results in 3 solutions. Perfect. Next. Any questions for me? A plus 1 times a minus 5 equals 7. What do I do? I have to use the 0 product principle. 0 product. So what will be my first step? Mandatory step. Say it again. Yes, I have no choice. I have to have 0 on one side. So then a plus 1 and a minus 5. How do I handle that now? Remember, 0 product. 0 on one side, product on the other. So what will be my next step? Of course. A times A squared, A times -5, 1 times A, -5, -7 equals 0. Perfect. Now what? Exactly. So I have A squared minus 4A minus 12 equals 0. And now I go through the steps for a trinomial. Descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, no. But at least 1 is the leading coefficient, which means I don't need a long procedure with factoring by grouping. I can go directly to factoring it because the leading coefficient is 1. So how do I factor this? The product of the numbers I'm looking for is excellent, and the sum is good. I need two numbers whose product is -12, one positive, one negative, and whose sum is -4. So then I have, thank you very much, I have two options. A could be, or that's it. Very good. Any questions on this problem? Any questions on this problem? Okay, next one. D, quantity D minus 3 equals 40. What do I do with this?
Make it subtract 40.
I have to subtract 40 and then, yes, D squared minus 3D. Excellent. There is no other choice. So now I'm looking for two numbers whose product is yes and whose sum is perfect. Since the leading coefficient is 1, no special product, no greatest common factor, and so on and so forth, I can go ahead directly to factoring it. And the answer for the factored form will be
D minus 8 equals 5.
excellent, thank you. So then I have two D's. One of them is, and the other one is good. Do we all agree so far? Okay. Two more here. X squared plus 7x minus 60 equals 0. Very similar to the previous two. Greatest common factor, no. Negative leading coefficient, no. Special product, no. But at least 1 is the leading coefficient. So I can go directly to factor it. I'm looking for two numbers whose product is very good and whose sum is perfect. Can I find those numbers? 12 and -5. 12 times -5 is -60, and 12 minus 5 is 7. So this is what I need. X plus 12, x minus 5. So then we have two options for x. One option is,
-12.
and the other one is, good, perfect. Last one, 1/2 x squared plus 5x plus 25 divided by 2 equals 0. We're not afraid of this. Why? Because we can multiply both sides by, exactly. Good. So when we do that, what do we obtain? What is the first step here? Careful. Yes. If I multiply, I have to multiply everything. Equals? 0 times 2 is 0, indeed. Trinomial, descending order, greatest common factor, negative leading coefficient, special product. If this is a special product, what will it be? Yes, what could it be? I covered the middle one. X plus 5, everything squared. But what is the middle term here? 2 times the first times the second. 2 times 5 is 10. 10 times x. Is this correct?
Yes.
Is this the same thing with this? Perfect. So I have two options here, however, they are both the same. Both the same with what? X equals? That's it. You will see in the next course what a double solution means. It's a double solution. It's the same solution twice. And you'll see what that means in the next course. Okay, last 6 problems from the handout. On the last page, page 6. Y cubed minus 3y squared minus 4y equals 0. What is the degree of this polynomial? 3. How many solutions will we find? 3 indeed. Good. It's a polynomial, degree 3, 3 terms, greatest common factor.
Y.
Very good. What is left in parentheses? Yes? Yes? Good. The polynomial inside, it's a trinomial, descending order, no greatest common factor, we already did. Negative leading coefficient, no. Special product, I wish. But it's 1 as the leading coefficient, so I don't have to go through the whole thing. I can directly factor it and then find 3 solutions. How do I factor y squared minus 3y minus 4?
Y minus 4, y plus 1.
Indeed. Y minus 4, y plus 1. And now we need 3 options. Y equals
4, and then
Do we all agree with 0, 4, and negative 1? Everyone? Perfect. 4. X to the 4th equals 100x squared. What is the degree of the polynomial? How many solutions will we find? Now you understand why we will not divide by x squared. That would be incorrect. But I can divide by? Yes. So please make a note. Never divide by a variable. Never divide by a variable. So there are certain situations depending on a lot of things, but keep this in mind as a general rule. Okay. But I can divide both sides by 4. So I get x to the 4th equals 25x squared. You understand that if you divide both sides by x squared, then you will only find 2 solutions, not 4. Good. What will be my next step? Remember, in the back of my mind, I have the 0 product principle. That's what I'm getting at, and that's what I need to use. So what should I do first? Right. X to the 4th minus 25x squared equals 0. If you forget to write the equal symbol and 0, you will not solve. You will only factor. And now, it's a binomial. It has the greatest common factor that I have to pull out, which is, yes, and it cannot go away. It has to stay. And then I have left what in parentheses? Very good. I know how to handle x squared minus 25. It's on the agreement, and we also spent 2 hours last time reviewing it. So what do I do with x squared minus 25? And I have 4 solutions. Yes, 2 of them are the same.
x equals 0.
Yes. X equals, and x equals 5. Do we understand this? Any questions? Is this okay? Okay. We have 3 more here. B cubed equals -1. Okay. In the back of my mind, I have the zero product principle. So what do? Yes, b cubed plus 1 equals 0. Now I have to think for a moment. It's a binomial, it's in descending order, no greatest common factor, no negative leading coefficient, special product. I always hope for 1.
Sum of cubes.
Exactly. Once you say sum of cubes, then I'm going to get ready a binomial times a trinomial. Binomial and a trinomial. Now I have to identify the binomial, but I prefer identifying the sequence of signs first. If this is plus, then what is the binomial? What is the sign inside the binomial? Indeed. And there must be a negative because otherwise those 4 terms will not go away. So it's plus, plus, minus. Okay, so what is the binomial?
B plus 1.
Of course. And then the pattern is I square the first, I square the last, and the middle one is just the product. Just the product. Without the 2. The 2 is in a different formula, in trinomials, not in binomials.
Minus B.
Minus b and plus
1
1. Yes. So, by the way, what is the degree here?
3.
How many solutions? Okay, so from here I have 2 options for now. I have that b equals from here, b equals, right? And the second option, b squared minus b plus 1 equals 0, will give us how many solutions? For a total of 3, I have to have 2 solutions here. Well, this is in chapter 11. I will not forget to get back to this. We cannot solve it right now. We don't know how. So I'm hoping that we get to that using quadratic formula, and we'll come back and solve it. Right now we can't. Okay, 2 more. X cubed minus x squared plus 4x minus 4 equals 0. Let's work on this for 1 minute. How many solutions will you come up with? Yes, 3 solutions. And in the meantime, I'll put my attendance. Very good. So it's in descending order, no greatest common factor, no negative leading coefficient. And since it's 4 terms, my only chance is good. From the first 2, I factor out good. What is left in parentheses? What do I have from the other 2? And do not forget to write the equal symbol in 0, otherwise you will not solve, you will only factor. This is crucial. Okay, so then what do I have from the other 2? It must be x minus 1, and then in front I need a sign and a factor. Plus 4. Now x minus 1 comes out, and what is left in parentheses? Good. So now for now, I have x equals from here 1. And from here, I have x squared plus 4 equals 0. I know how to solve this from chapter 10. And I will get 2 more solutions. So how do I solve this equation? In chapter 10, I learned to do what? This is not a square radical equation. I cannot square. I subtract 4. And then, this is a very important method. What did we do in chapter 4? Which operation did we apply to both sides? The square root. Then the left-hand side should be the absolute value. Instead of that, what do I write on the other side? Indeed. So now let's think about this. The square root of negative 4 is the square root of negative 1 times the square root of 4. What am I getting at? 2i. Thank you. So now we do have a total of 3 solutions. This we were able to solve. This we were not able to solve till the end of the day today, I think. I hope to get there. Good. So here are our 3 solutions for this equation. X equals 1. This is a real solution. These 2 are imaginary, but they're still part of those 3. So 1 solution and 2 here for a total of 3. Last problem. 3x cubed plus 2x squared minus 27x minus 18 equals 0. 1 minute. And then we'll start chapter 11. So of course, this is a polynomial. We repeat what we just did. From the first 2, what will I factor out? Very good. X squared indeed. What is left? What should I have coming out from the other 2? I have to have it here, an equal symbol and 0. If I forget the equal symbol, I will only factor, not solve. So I have to have 3x plus 2. And then in front, I need sign. I cannot omit the sign. Sign and factor. So now I pull out the comment. I forgot to ask you, how many solutions are we looking for?
3.
Good. So then I have 3x plus 2 and x squared minus 9. Don't forget the equal symbol and 0. I know how to handle x squared minus 9. What do I do to it? So now here are our 3 solutions. In any order, it doesn't matter. Exactly, excellent. Very good. So with all this preparation, it normally takes me a month when I teach O11. What we covered last time in 2 hours and today in 1 hour, less than an hour, it takes me about a month in O11 to do. Because it's a very good technique to have moving forward for any math class that you're taking after this. It's a very powerful technique. Knowing how to factor is really a powerful technique. It's like a skill that you have. Okay? So please remember that. This handout covers everything. So if you know what's on this handout, you should have absolutely no difficulties with factoring. Okay, so let's start chapter 11. Chapter 11 is about quadratic equations and functions. And you can say again, Yes, because we haven't graphed those functions. We only looked at equations. So quadratic equations and functions. And I'm on page 7. Okay. So here's a quadratic equation in the general form. This is the standard form, if you want, of a quadratic equation. A, B, and C are real numbers. I claim that A cannot be 0. How come? Why? Why A cannot be 0? B can be 0, C can be 0, but A cannot be 0. What happens if A is 0?
Not quadratic.
It's not quadratic anymore. What does it become? Linear. That's why A cannot be 0. Good. So 4 methods of solving quadratic equations. And you can say, really? Do I really need 4? The answer is yes and no. And I'll tell you why yes, and I'll tell you why no. One of the methods alone cannot solve quadratic equations. So I would say 3 methods are extremely good to know because they apply in different situations and make your life easier. The 4th one, no. We learn it now because of something else that follows in algebra in the next course. That's why we learn it here. But it alone cannot solve a quadratic equation. Okay? And I'll tell you which one in a second. So the first method is factoring. I'm done with that. And I hope you are too. Number 2, taking square roots. I'm going to write done because we had examples in chapter 4 and today, but I will start with few examples today. Number 3, completing the square. Not useful. This is the one I was talking about. Not useful here. Very useful for something else. That's why we will study it here. But it alone cannot solve. This one alone can solve. This one alone can solve. This one alone cannot. So after I complete the square, I have to use this method. So I wouldn't even list it here. I will list it as a side byproduct if you want. But it is listed and I will have to talk about it. So it's an important method for something else. Will it partially solve a quadratic equation? Yes, but partially. Alone? No. It has to be followed by this one. And the last one is the quadratic formula. So students ask me, okay, now you listed those 4. When do I use what? Okay, when I will apply which problem or which method to a problem. Here is my explanation. This one never for solving quadratic equations, unless you are forced to, and you will be forced to, on this, at least on one problem in the next test and one problem on the final exam. It's an important method. It is useful for something else. So we have to learn it from now. So if you ask me when I apply this, my answer is never. Unless you force me to. And then I have no choice. When do I apply this? Only if it takes me 1 minute to factor. If it takes me 2 minutes, I'll say, no way, I'm going to use this. I'm exaggerating. You know what I mean? So if it's quick, not with big numbers, I will definitely factor. But if it takes me more than a minute or so, I will say, oh, I don't need that. I will go ahead immediately with the quadratic formula. This does not always work. Not all polynomials are factorable. This will always work. This combined with this will always work. This one will not always work. So now bottom line is, where do I apply this? Only in specific situations. When I have something squared x inside, something squared x inside, and just a number on the other side. If I have any other setup, I'm not going to use this. So if I have something squared with x inside and a number on the other side, I'll take square roots from both sides. One more time, everything works except that. Sometimes polynomials are not factorable, so I cannot use this. If it takes too long, I'll apply the quadratic formula. This one, never. This one, in specific cases only. So we do need to know all four methods. Okay. I'm going to go back to a few examples from taking square roots. And I'll let you choose, of course, if you want, on page 659. This is 11.1. The title of this section is Completing the Square. Well, in a minute. We're not there yet. So we are in 11.1, and we are completing the square, but not yet. I still want to talk about taking square roots. So please choose anything you like from 1 through 26 on page 659. Okay, I will choose 13. So 2x minus 3 everything squared equals 8. This is a typical situation for taking square roots, because the left-hand side has something with x in it and it's squared, and the other side is just a plain number. So I take the square root from the left and the square root from the right. Now remember from chapter 10, and also remember how many solutions I have to get here. Because I don't want you to forget 2. Because I don't want you to forget plus or minus. If you forget plus or minus, you only get 1 solution out of 2. So, because remember, we skip the intermediate step. I disagree, but that's what it is. This is the intermediate step. And that's why from here we have 2 solutions. I'm sorry. That's why from here we have 2 solutions. Instead, we write 2x minus 3 equals plus or minus. And since we learned chapter 10, in which we split the square root of 8 into the square root of 4 and the square root of 2, then I will have to write 2 the square root of 2. Then the next step is I have to move 3. Please be careful. You cannot move 3 between 2 and the square root. You cannot move 3 between the plus or minus and 2. You have to move 3 right here after the equal symbol. So 2x equals 3 plus or minus 2, the square root of 2. The final step, we have to divide both sides by 2. Be careful not to simplify. Here are 2 ways. The first way, and here's the second way. The first way is this. You cannot simplify. Here's the second way. In the second way, you can simplify this and this, nothing else. So in the second way, although the solutions are both the same, I accept both. This is perfect, this is perfect. Just wanted to show that you cannot simplify in a sum. I would like to look at least one more, if you'd like to choose. Which one? 25, very good. X plus 3 everything squared plus 8. X plus 3 everything squared plus 8 equals 0. Excellent. It's typical situation for taking square roots, but it's not set up yet. Remember, have to have something squared with x inside, nothing else attached, equals a number. So what will I have to do first? Yes, x plus 3 squared equals negative 8. It's a very useful method of taking square roots. So I will take the square root from the left and the square root from the right. If I omit the plus or minus, I will only find one solution instead of both. So careful on that. Very easy to forget. Now, how do I split the square root of -8? Well, obviously the square root of -1, and then the square root of 4, and then the square root of 2. So what is left on the other side? Plus or minus 2i, exactly, 2i the square root of 2. The only final step that I have to perform is put 3 between this equal symbol and plus or minus. Nowhere else. Any questions on this? So x equals -3 plus or minus 2i the square root of 2. Okay, so I would say then that this is indeed done and this is indeed done, and now we are ready for completing the square. Okay, as the third method. So completing the square is a method that will partially help in solving a quadratic equation. It alone cannot do the job. Let me give you an example so we can discuss about what completing the square means, and then we'll look at an equation. Here's my question to you. And you could say, what is this? And I will answer, I would like you to figure out something here such that this, when you square it, you get these 3 terms. Right. It has to be 9. Because we know the formula, or the special product, of x squared minus 6x plus 9 will give us, this is the only way. I cannot have anything else in here. And what will I get? That's it. We've been talking about this from day one, right? This is the idea of completing the square. So I found a number that together with the other 2 terms will form something squared. I completed the square. By finding this number, and that's the method we are going to apply in solving equations. By finding this number, I completed the square, I changed this into this, so that I can solve by taking square roots. Okay? Let's start with an example, and then I'll write the procedure for you step by step. Let's say problem 36 on page 660. And we have y squared plus 6y equals -8. You can say, yeah, I'm going to move 8 to the other side. I'm going to factor into y plus 2y plus 4, and I'm done. True. We are forced to use completing the square. So I already know what I need, and I will have to add it to both sides. What do you think we're going to have to add to both sides? What will I have to add to both sides so then these 3 terms form a perfect square?
3.
Squared.
9.
Right? Because y squared plus 3y plus 9 will be a perfect square. So here's the step-by-step procedure. In step number 1, identify the middle coefficient. But it has to be in descending order. Otherwise, I won't be able to identify it correctly. Identify the middle coefficient. In step 2, so what is the middle coefficient in our problem? 6. In step 2, divide 6 by 2. What do I get? 3. In step 3, square 3. Okay, how much is 3 squared? 9. That's how I get the 9. And in step 4, add 9 to both sides. Okay, now let me ask you this. Am I allowed to add 9 to both sides in an equation without changing the solution? Because if I'm not allowed to, then I can't use this. So imagine y squared plus 6y equals -8. So I have here on one, I have a balance. So I have here y squared plus 6y, and I have here -8. Now if I add 9 pounds to both sides, will I change the balance? No. If I subtract 3 pounds from both, will I change the balance? No. So I'm allowed to add 9 to both sides. The solution will not change. Which method in chapter 10 we applied, but we said, uh-oh, this is not fully legitimate. I have to go back and check at the end.
Principle of power.
Exactly. We raised both sides to a power. Then we said, uh-oh, this is not fully legitimate. We had to go back and check, but not here. If I add 9 to both sides, I'm fine. Perfect. So I have now, but do you remember, you have to add to both sides. If you only add to one side, then you change the problem. But if you add to both sides, you're not changing the problem. Good. So now I completed the square because I know the left-hand side can be changed into blah blah squared, and the right-hand side is 1. What do I have on the left? I made it happen by choosing 9. Y plus 3. After all this effort, I complete the square, and I'm looking at you, and we say, what? We didn't solve. It's not done. I have to use taking square roots. So complete the square alone is just halfway, half the solution. The other half is done with another method, which is taking square roots. So then y plus 3 equals, and if I forget something very important, I will only get one solution, not both. Plus or minus 1. Remember, I moved 3 between plus or minus and the equal symbol. Nowhere else. Since I can simplify them, I must separate them. And I separate them and I get y equals and y equals. -3 plus 1 is -2. -3 minus 1 is -4. That's the method of completing the square. Give me 1 second.